Hello and welcome to this training course on BricsCAD BIM. Today we're going to talk a bit about structural modeling in BricsCAD BIM. So we're going to talk about how to create columns and beams, members, how to use the linear solid technology to create those structures, and how to use the PROPAGATE command to easily copy details and connections over from one location in your drawing to another. Using all of these tools, we will create a simple structural or a simple steel shed. So let's open BricsCAD BIM and dive straight in. Okay, let's create a new drawing based on the BIM millimeter template, and we'll start off by creating a rectangular grid, which we can find in the modeling tab of the ribbon, rectangular grid here. And we'll just start somewhere close to the origin and create a grid of let's say 20 by 35 meters with grid cells of 5 by 5. Like this. And we'll also create a slab underneath our grid. I will explain later why we need to do this. Right. So now on one of the grid intersections, we're going to create a column. And to do that, I will open the Profiles panel. So the Profiles panel can be found here. If you don't find this here, you can right-click the ribbon and under Panels, go to BIM Profiles. So as we saw in the previous chapter, we can find all profiles here that we have in our library. That includes structural steel profiles, but also pipes, ducts, and so on. In this case, we'll focus on structural steel, focus on the European standard, and I will choose an HEA 300 profile. I will simply drag and drop the profile into my drawing, my model space, somewhere, an empty space in my model space, so I can start modeling. Make sure your snaps are on. In this case, I'm using intersection snapping. And I can snap here to the intersection of two grid axes. I'm going to make sure my polar or ortho mode is on so I can snap to the vertical axis like this. And we're also going to press Q and enter to quarter turn our profile to make sure we have the correct orientation for this exercise. And we'll enter a dimension of 5 meters high, like this. I'll press enter again to exit the command. So this creates a 3D solid. It's a linear solid because we have a profile attached to it. And also we see it's already automatically classified as a column. So the classification type that's applied when creating a linear solid is based on the profile type that's attached to it. In this case, it's structural steel. And because the solid is perfectly vertical, it knows it's a column. If this would be horizontal, it would be classified as a beam. All right, so now we're going to copy this column over to the other grid intersections. And for this, we're going to use PROPAGATE. It's a bit faster than manually copying it over. But if you want to just use the copy command, that's also up to you, of course. Or if you want to use the array command, that's also an option. Now in this case, I will use PROPAGATE, and that's actually the reason why I wanted to have this slab here. Because one of the restrictions or limitations of PROPAGATE is that it can only work with solids as its reference solids. So if I start PROPAGATE, the first thing it asks me is select the reference solids. These are the solids that make up the context of the detail that we're going to copy over. And in this case, yeah, we want to copy this column over to all the grid intersections, but this grid is actually not a solid. It's a block reference, a special type of block reference. But PROPAGATE is smart enough to know that if it finds a grid, an entity classified as a BIM grid, on a slab, it will know to search for grid intersections. So you will have this extra option in PROPAGATE to copy the detail over to grid intersections. So I will show you what I mean by that. So select reference solids, which will be my slab, my base slab. Press enter, and then it asks me to select detail objects, which is the object we want to copy over, in this case the column. So I select the column and press enter. Now before pressing enter, I will see what my options are, and the default says here yes, copy as block. So that will mean it will create a block definition of this one column and create references of this block definition when executing propagate. Actually, in this case, I don't want to create blocks. I want to just copy the column as a solid, because that will give me more freedom in a later stage to use this for further propagations, for further direct modeling, and so on. So I will choose to copy plain. So yes, plain copy instead of copy as a block. And now here I can see it gives me plenty of options. So the default option here is it finds that there is a grid on my base slab, and it will give me a suggestion or a detail for each grid intersection here. I will take a look at the widget here, and I can see there are three options here. The first one is the BIM grid, which it detects on the slab. If I select this, I can choose to explode this or keep it as a main grid like this here. I'll get back to this later. First, I'll check out the other options. Similar location is it will find basically the extents of my base slab or see what the situation is around my detail, and will find similar locations in the slab. So it finds here it's close to a corner. It finds three other corners, and it will place these columns close to the corner on the same location with respect to the corner edges here, the slab edges. Which I can then also explode if I want to. And then the final option is, if I don't have a BIM grid on this slab, I can ask Propagate to create a grid for me, a temporary grid. And basically divide the number of columns here over this temporary grid. So I can say, okay, I want to have 5 columns and 6 rows, for instance. You can add columns and remove columns, add rows and remove rows. And then again, explode this this suggestion. So that's easy if you want to quickly create an array of entities based on or on top of a slab or a plate or whatever. So these are the 3 options I have in this case. I will go back to the BIM grid, which will use the grid that we created before. So again, on each grid intersection, it will create a column. And I will choose to explode it. So instead of just pressing enter and accepting all of these columns here, I will explode it, which will turn this one suggestion of, I don't know, 40 something or 60 something columns into separate suggestions, which I can now separately enable or disable. So in this case, actually, I only want the outer 2 rows here, so these 2. So I will select all of the other ones with a box selection like this. Click one of the ones here, select it to turn it off. And I can press enter to delete these suggestions from my context here. Okay. So that leaves us with all of these suggestions, which is actually fine by me. So I will press enter again to apply it. So I have my 16 columns now on the outer edge of my slab. Okay, we're going to create a truss now. To do that, I will focus on just these two columns here, I will isolate them and we'll work with these two columns to create a truss in between and then copy it over again. Right, before I get started on this, there's a few settings I want you to be aware of. First of all, let me go to the structural/MEP tab in the ribbon here. And I will enable the display axes option. So this will, for linear solids such as columns and beams, but also pipes and ducts, make my solid itself slightly transparent, and it will create or display the actual axis of the solid with a red line. So this helps me visualize where the axis is, and it also helps me snap to the axis. So let's say I want to draw a line here, and I want to snap to the axis here. So this is actually a snap option called endpoint. But you see, if I want to create this line, I want to snap to this endpoint, there's all of these other snaps that are getting kind of in my way, because this is, I guess, quite intricate geometry. It finds midpoints, center points, endpoints, and so on. To make this snapping a bit easier, there's a special snapping mode called BIM OS mode. So let me go to the settings dialog here and type in BIM OS mode, BIM object snapping mode. And this gives me two separate options here. The first one is this axis of linear solid. So basically what this does, it overrules entity snap modes for BIM entities using bitcodes. So it overrules the normal snapping in the vicinity of a linear axis, or linear solid axis. So if I enable this, and I want to draw a line again, you see it doesn't snap to the other places here, it only snaps to the endpoint here of my linear solid. So that makes it easier to snap to linear solid endpoints or midpoints without being bothered by other geometry. So that's quite useful to keep in mind if you're working with linear solids a lot. Okay, we're going to create a truss now between these two columns. And we'll do that by just creating some a line drawing first. I'm actually going to draw my line or my line model in 3D, my wireframe model in 3D, but you can also create this first in a 2D drawing and then later turn it into a 3D model. So I'll snap from linear solid axis endpoint to endpoint. I will move this line down a bit. And I'll create a vertical line here, 1400. And create another line here to the endpoint of this linear solid. And now I want to create triangular trusses here in between. Now there's several ways to do this. The way I'm going to use is I'm going to use the divide command to create point objects which I can easily snap to. So I will divide this line here in 20 segments, and this one here I will divide in 10 segments. And I'll start drawing lines like this. Make sure your node snapping is enabled. Node here, so you can snap to these point objects. Like this. Okay, we're going to get rid of our temporary points that we created that we don't really need anymore. So these points were created by the divide command. I will remove them. And I'll take all of these lines here actually and copy them over to the other side, or mirror them over to the other side. I'll do that using the manipulator. Like this. So by the way, I used the Control key. I held down Control while using the manipulator to copy it while mirroring it. Otherwise, you will just mirror it without copying it. Right, and now let's apply some more profiles to this line work here, this frame wireframe model. Again, using the profiles panel. So these are beams, which means I will go to the IPE profiles. I will apply IPE 240 to the lower beam and IPE 200 to the upper beams. And for all the other ones here, I will use IPE 100, or sorry, IPN 100. Like this. Okay, so after applying these profiles, you will see, so this is a column, this is a beam. These ones are members because they're not vertical or horizontal. And you will see actually these two larger ones are also members because, again, they're not horizontal. You can still reclassify them as something else. I guess in this case we would classify them as a beam, which we can do easily in the BIM tab of the ribbon, or the quad, sorry. Classify as beam. Right. Okay, let's show the rest of the model again. And now we want to copy over this truss to the rest of the pairs of columns. Again, we're going to use PROPAGATE for this. We can see here, so the reference solids, which are the solids that make up the context of the detail, would be the two columns. And all of the other entities, these truss entities here, are the detail objects. So launch PROPAGATE, choose my two columns as reference solids, choose my detail objects, and press enter. And again, it will suggest to copy it as a block. In this case, we're going to use plain copy. Depends on what you're going to do later with it. Sometimes using copying as a block is a better solution because it keeps the file size smaller and keep things more manageable. But for this exercise, we'll just use plain copy. And it will find 15 suggestions. As you can see, it finds suggestions not only here at the top, but also at the bottom. Because that's actually because the two columns, well, they're symmetrical top and bottom. So it finds similar locations at the bottom here as well. So let's just select all of these suggestions here and turn them off. And all of the others we will enable. So that copies over these objects quite easily, quite quickly. We're going to create some horizontal bars here, so horizontal beams between these columns. For that, we're going to hide again the slab and this grid. And I'm going to open the profiles panel and search for a U-shape UPN 120. I want to snap to the outside of this profile, but I can see actually it doesn't let me snap because I have my linear or my axis shown and my BIM OS mode is still enabled. So I can't snap to this particular point here. So I need to disable my BIM OS mode again. Now I'll snap to here and to the next column there. And so as I can see, when you start modeling with this profile, so I snapped to this point, and it modeled the actual linear solid with the axis where I pointed my cursor, or where I snapped. So that means actually that the center of my profile is at the place where I snapped, which is good, but the geometry itself is actually clashing with my column. For this we also have a solution. So it's possible to create an eccentricity of your geometry with respect to the axis of your linear solid. So this eccentricity you can find here, again in the structural/MEP ribbon tab, add eccentricity. So I will select this beam here, and it gives me an option to where I want this eccentricity, or in what direction I want it to be eccentric. So I could say, for instance, I want my geometry to move with respect to the solid axis to the left here, so that now it's on the outside of the profile. I could also choose the other direction, or have an eccentricity vertically, or a combination of the two, like this. So in this case, I'm going to create an eccentricity like this, so that the horizontal beam is no longer clashing with the vertical column. And press enter. And I will move this beam as well upwards, like this. I will actually also copy it over a few times vertically. To do that, I will hold down the control key, like this, and hit C for copy, or actually repeat, over a distance of 900 mil. And it allows me to create a copy repeat like this. I'll create 4 copies. And there we go. We're again going to copy this over using PROPAGATE. So go to the PROPAGATE command. Again, choose my 2 columns as reference solids. Choose my bars as detail objects and press enter. And again, I will use the plain copy option. So it finds again all of these solutions, all because my columns are equally spaced and have the same profile, the same geometry. So per option I still have several sub-options. For instance, inner, outer, lower, upper, basically. So in this case, I want it to be on the outside and the upper half. So I guess option 2 is the one that I want. I can manually fix them like this. Okay, and I'll press enter. So now we have the basic geometry of our structure there. Now we'll start cleaning up some geometry, because as we can see, we have some clashes between members, beams, columns, and so on. So we'll start cleaning this up. We'll start with the beginning. Start with these 2 beams. So we can see that the axes of the 2 beams are actually connected, but the geometry itself is not in any way connected or solved for this particular context. It's literally just an extrusion of a profile along this axis. However, we can solve this automatically or manually using direct modeling. But in this case, we will use the structural connect tool, asking me to select solids to connect. It works on linear solids with structural steel profiles. I can simply select those two solids here. I can toggle between different options. Depending on the situation, it will give you good options, and then we'll just go for the mitered one. So this is kind of a generic solution or generic tool to solve connections, which means you can find solutions for any kind of connections, but sometimes you will get some strange or crazy results depending on the type of connection that you're looking at. So we have this solved now here for this first truss, not for the others one. I could again go manually like this and use the structural connect tool. Or I can have multiple at once like this and choose the structural connect tool. Or again, I can use PROPAGATE to do the heavy lifting for me, to find where I can find similar locations. And apply it to the rest of the beams like this. All right. Next up is the connection between this column and two beams here and this one member. Slightly more complicated. We'll start off with this first node here. So I'll just select the three entities and use a structural connect. And it should find a solution for me based on certain rules. So usually it prioritizes columns, then beams, then members. So it first cut away the beam and then the member. We can try a similar thing at the top here with the beam and column. So it gives us a mitered connection. I can hit Control to find other solutions. Okay, and let's choose this one here. And actually, I'm going to still edit this a bit, manipulate it a bit to, first of all, pull it all the way to this edge. And then to also slice it up. So the end is vertical, like this. Now you notice, because I did this manual manipulation of the end of this beam here, that my axis was recalculated. So the axis is no longer, well, it's connected to the beam, or to the column here, but also runs to the end. If you want, you can still fix this by simply using structural connect again. Go for the second option. It doesn't actually change the geometry, but it only changes the axis here. Okay, let's assume this is the connection that we want. So of this node and this node here, we can actually combine all of this in one single detail for PROPAGATE to have it copied over to the rest of the drawing. So use PROPAGATE, select my four entities, so my two beams, column and member. No detail objects in this case. And you will see it creates this detail volume here with indicated in purple the solids that enter this detail object, so kind of the boundaries of the detail object or the detail volume. And press enter. And it finds again all of the edges or the corners here and will apply this detail everywhere. So that looks good. Okay, this exercise comes with a folder with details that we can reuse over a certain project, over different projects. And this details folder you can use in the details panel. So the details panel here we can open. If we go to the Manage Libraries button here, go to directory, go to the details directory path, and add a path like this. Add path. Click 3 ellipses here, and you can select the folder that was delivered with this exercise, where you will find a sample detail that we can reuse. I've already done this actually, so I should find this detail. Maybe I haven't done this yet, so let me do it manually here. So go to Manage Libraries, add a path, go to the exercise, and I'll select this details structural folder to be part of my path list. And I have now, in this folder called structural, I have some details that I can reuse for this project here. And in this case, this is the one that I'm looking for. And we will propagate this. So basically it's a connection of two smaller members to a non-horizontal beam like this, where it will create these extra stiffener plates here. And I will propagate this. Now in this case it takes a few seconds because it needs to find all of the possible connections. There's quite a few of them. So let's just let it run. Okay, so there it found 152 suggestions. So that's quite a lot of suggestions here. So every location where it finds two members of this profile coming together with a beam of this profile, we will see that these stiffeners will be applied. But actually this case is quite slightly more complex, because you can see here that the angle of these two members is different than, for example, the angle with these two members. That's possible because the detail that we're applying here is actually a parametric detail. So let me just first accept all of the situations here, the suggestions here. I'll just let it run to create the geometry, and then I'll explain a bit how the parametric detail works. So that's done, and we can see that the geometry is now properly applied everywhere. So the detail that we applied was this one, this truss connection here, and we can see when we open it that it's parametrized, and there's some tolerance parameters. So there's an angular tolerance of 45 degrees, profile dimension tolerance, which means I could also apply this detail with profiles of different dimensions. So eye profiles coming together, but if the beam is slightly larger or smaller, it will still find solutions. And also some offsets if the beams are not perfectly centered in the same location. So let me open this just to show you what it looks like. So we have our detail volume, which is this here, our detail or our base solids, which are the beam and the two members, and then some detail objects, which are the stiffeners. They're created on a dedicated layer called detail objects, detail section, detail volume, and base solid. And we will also see, if we open the parameters panel, that there are some user parameters such as angular tolerance, dimension tolerance, offset tolerance, which were the properties you saw in the dialog box earlier, and then some actual members. Some actual parameters. So, for example, there's this angle of this first member, angle of the second member, or sorry, first member, but other angle, so another axis to rotate around. Actually, all of these parameters and constraints were automatically created. So there's an auto-parameterize option when creating a detail. I'm not going to explain now how this all works because it's quite technical. It's going to be part of a later training session or a later chapter. But just know it's possible to create fully parametric details. Also, in this case, offsets. So that's in this case the offset in this direction. Sorry, it's difficult to see here. So even if my member here wouldn't be perfectly centered with the actual beam, it would still find solutions. So within these tolerances of these parameters, it will find solutions to apply this detail. So as I mentioned, this was created automatically. It's also possible to do it manually, but that's even more difficult. So again, that's going to be a subject for a later chapter. Right, so we'll create a more detailed connection between the main column here and this larger beam. To do that, I will isolate both entities so we can focus on this. Actually, I'll turn off my axis display as well because it bothers me a bit. And we're going to create a bolted plate connection between these two members. So BricsCAD BIM is not a structural detailing solution, let alone a structural analysis solution. We can create details like this if you know how, and if you have the time and patience for it. It's possible to do it manually or create a library of details again and copy it over. So I will create, first of all, an end plate, just using a modeling tool to create a box like this, thickness of 10 mil. And I will push-pull outwards over distance of 20 mil. I will enable my subtract. So you see here there's in the command line, enable or disable subtract. If I keep it enabled like it is by default here, it will subtract geometry from entities it is clashing with or interfering with while doing the push-pull here. So I'll just press enter, and you see it actually subtracted geometry from this beam here, so they're no longer interfering. I'll do the same on the other side. And now we're going to add some bolts. So let me go to the library here, and I want to make sure that my Bricsys mechanical library is enabled. If you have this enabled, you will see things like standard parts, sheet metal, and so on. So let's go to standard parts and find fasteners, bolts, hex head bolts, ISO, and let's take this ISO 4015 here, and you see while placing it I can still change the part number, size, length, and so on. Let's just place it with the default values, and I will choose a distance of 30 mil from the side, hit tab to go to the other dynamic dimension, and hit 55 here to place it. Now again, we'll use propagate to copy this over this plate. So remember in the beginning of the exercise where we copied the column over the base solid or the base slab, we had the option of using the BIM grid, similar locations, or grid. If I now use propagate on this plate here and choose my bolt as detail object, I will get two options, similar location and grid. So we don't have the BIM grid option anymore because there's no BIM grid available here on this plate. We'll create a grid and we will add a row like this. So we have 3 rows and 2 columns like this to copy over this bolt over the plate. I'm going to create an extra support here by extruding this bottom face here over a distance of 15 mil and push pulling this over a distance of 40 like this. Alright, so we just used some simple modeling tools like push, pull, and extrude to create these plates. So these are just 3D solids, just generic solids. Let's attach some BIM information to it by classifying them as the correct classification type. So these 2 entities are actually plates, which I can choose to classify here, classify manually. And under structure elements, there's a plate type. I'll also select the 6 bolts here and also classify them as mechanical fasteners. So these are entity by entity classified as mechanical fasteners. And now we could actually select this entire thing, so 2 plates and 6 bolts, and classify the whole thing as a building element, which is kind of a generic type. Before I press enter, I will make sure to convert to block and classify the block reference. So if I would leave this unchecked, I will overwrite the classification types I just applied to them. If I check this, it will create a block reference, so it will group all of this together into a block and classify this block reference as a building element. Let's choose okay. And now we have one block reference, which is classified as a building element. Right. Okay, now we're going to save this detail into our library. So we'll open the details panel. And let's create a detail here using the big blue button. So here again, it actually asks for the same steps as in propagate, so it reference solids and detail entities. So reference solids, I can select them by clicking here, pick reference solids. In this case, it's a column and beam coming together, so these are the reference solids. Press enter. My detail entities, which in this case is the block we just created. A section is not necessary in this case. So section planes are necessary for propagation between planar solids, such as walls and slabs, for example. But for linear solids, it's not necessary because the detail volume is actually a 3D volume. whereas for planar solids, the detail volume is more of a planar or two-dimensional detail. Let's give it a name. Bolted plate connection, for example. Let's choose a category. So we get this Save Detail dialog box here, or we can see a little preview of our connection, the name we gave in and the category. We can add some tags, for example, if it's part of a certain project or certain entities or material types are used, you can add this as a tag so you can more easily find your detail in the library later. And you can edit the thumbnail as well. So if I hit this pencil here, I can still move my camera around, so I can have, let's say, a 3D detail like this, and press enter, so it appears with the proper thumbnail in my panel. And let's save this detail. Okay. And now we can reuse this for the rest of our drawing. So instead of doing propagate, which reuses the detail once, we can save it in our library, which we just did. We can reuse it for other projects, other drawings, and so on. So under structural, there's this bolted plate connection, which I just created here. And I can choose to click propagate here, or I can simply drag and drop the detail into my drawing, and it should find all of the other locations where it can apply this detail. There we go. So let's press enter. Alright, so now it's applied this block here to all of the other connections. If I select this this block and choose select similar, we find we have actually 15 of these block references in the drawing. Okay, that's everything for this module on structural steel modeling. I hope you found it useful, and thanks for watching.